Welcome back, Algebros. We return to the land of functions, this time with one last adventure in mind, on transformations. We've already talked about what makes a function. But what happens when we want to change and shift them around? Because when you think about transformations, we're thinking about transforming or changing it into something. And that's all this is really going to be. We're going to take a base form of a function, which will oftentimes be denoted by our buddy Dotson, and we're going to change it in a variety of ways. For the purposes of simplicity, we will focus mostly on shifts, stretches and squishes, and flips. And there is a way that we can tell by looking at an equation how that graph is going to stretch or squish, or flip, or shift. Well, let's get some definitions out of the way. When I say shift, I'm talking about moving the object as is. And that goes for the function as well. That could be a horizontal shift, like I'm pushing a box, or a vertical shift, as if I'm lifting it over my head, which wouldn't be possible. I'm too short for that. Speaking of shortness, stretching and squishing might be able to help, or hurt, in that regard. These words are directly at odds, because when I stretch something, I'm taking it from the top and pulling it up, and from the bottom, pulling it down. So the result of a stretched Dotson, poor guy, will look something like this. Meanwhile, a squished Dotson will actually go in the other direction, where the top is pushing down and the bottom is pushing up. So a squished Dotson, once again, poor guy, might look something like that. Finally, flipping is exactly what it describes. We're mostly going to be referring to this as a vertical flip. So, we have something facing up. If it flips, it'll then face down. So if Dotson normally looks like this, when we flip him, he looks something more like that, from a vertical flip. That's what the changes will look like, at least the ones that we'll cover in this course. But I will give you a little bit of a heads up. We are going to be using a notation called f of x to refer to functions, and that's basically like saying the same thing as y. I just want to give you that heads up in case you read it in any books, or when I start using it without even thinking. With all that out of the way, let's get started.